First page, we did some of these graphing ones yesterday. Let's take a look. We have problem 6 up there, but I did that one yesterday. Oh, yeah. I did 6 yesterday, so let's skip that for now. If we need to look at it again, I will. Did we need 5? It was similar.
No.
Okay. So problem number 8. We are telling transformations. So remember, all of our different transformations. The trick I told you is if you add to x, it goes to the left. So if you subtract from your x, it will go to the
Right.
If you add to y, it goes high. So if you add to the y, it goes up. If you subtract from the y, it goes down. A negative in front, what does that do?
Flip it.
And then we have, if you multiply by something, that is your vertical
Compression. Stretch.
stretch if the number is bigger than 1, compression if the number is between 0 and 1. Okay, so that's kind of our run through of all of our different transformations. If you struggle with this, let's talk about using our resources. So you're taking the test, and I give you one of these, and I ask you to tell me the transformations. If you are not exactly sure, what could you do? Put it in Desmos. Could you look at a graph on Desmos and then tell me how did it move from there? Absolutely. Or your graphing calculator. So you're not only expected to be able to look at this and tell me. You can use your other resources if you need to. So if I'm looking at number 8, we aren't multiplying by anything, so there's no stretching or shaping. We don't have a negative, so we're not flipping. If we add to the x, it goes left. And I don't want you to just say the word left. I want you to tell me how much. So it goes left 4. And then the 1 on the end, that's like affecting our y. So if we minus 1, it would go
Down
1. All right, number 11 is asking me to write the equation. So we're starting with the y equals x squared. If it's vertically compressed by 1/4, what does that mean?
See, and I thought that, because like on the example problem, you had like 5/1 and then 1/5. So and since it was 1/4, I put 4/5.
Oh, you flipped it. Yeah, I think on the example we were just talking about the difference between the two. So on the stretching or compression, I will give you the actual number that goes in front. So it's a 1/4. If it goes right 7, what do I need to do with my x? Minus 7, and that's squared. And then it goes down 1, so then it would get a minus 1. Now, on the test, if you're not sure if you wrote your equation correctly, what would you do now? Graph it on your calculator or Desmos. I don't care which. I'm going to allow you to use it. So graph it and see, is this really what it should look like? If not, what do I need to fix? All right, if you're struggling with, where does my square go? Look at some of the other problems on your test. There's probably some written similarly that can help you figure that out. All right. Let's look at problem 16. So this one we hadn't gotten to yet. If I wanted you to factor this, first we have to multiply it all out. What would we do with the x minus 3 squared? What does that mean?
Twice.
Okay, so we have to FOIL. So that gives me x squared minus 3x minus 3x plus 9. If I combine my let's just go ahead and distribute. If I want to distribute there, so take my 2 through, get 2x squared minus 6x minus 6x plus 18, and I still have that minus 18 on the end. now, like terms, we have 2x squared. Negative 6x and negative 6x would be negative 12x. Positive 18 and negative 18, what happens? So now I want you to factor that. What would you do? Gray's common factor, if we take out the 2x, then what are we left with? X minus 6. Okay. Zeros. How do we find the zeros when it's in factored form? You set each one of those equal to 0. So 2x equals 0, or x minus 6 equals 0. By 2, so that gives us x equals 0. Add my 6, x equals 6. If you wanted to double check yourself, I want everybody to do this for me. Open up Desmos. And I want you to graph the original problem. Make sure it's charged tomorrow because I only have one charger. Alright, so go to Desmos and I want you to graph 2 times the x minus 3 squared minus 18. Graph the original one. The 2 parentheses x minus 3 squared minus 18. If you don't have your Chromebook, look over at somebody next to you. Okay, if I'm wanting to check my work, if I want to see if I have the right zeros, what am I looking at on this graph? Where it hits the x-axis. Does that graph hit the x-axis at 0 and 6?
Yes.
Yes, so we did our work correctly. Any questions there? Let's look at problem 17. So I'm asking you to write the equation from this graph. Alright, so this is kind of really testing if we understand the relationship between these things. If I'm looking at this graph, what are my zeros? Where does it hit the x-axis? Okay. So if negative 4 is a 0, can you guys tell me what would be in my factored form? It would have a positive 4, x plus 4. If 2 is a 0, then this would have an x minus 2. Standard form is ax squared plus bx plus c. So if I multiply this out, we get x squared plus 2x plus 4x plus 8. If you add like terms, x squared plus 6x plus 8. So that is my standard form for that graph. Alright, so if I gave you a graph, could you guys look at it, find your zeros, and write the two factors? And if you wanted to check yourself, what would you do? Yeah, graph this and see if it's the same as what we started with. The vertex form is using transformations. So think about x squared normally is up here. So did we move this graph left or right? It went left how far to get to our vertex? Left 1. So that would mean it would have an x plus 1 squared. And then my graph moved down 9, so it will get a minus 9 on the end. Alright, so be prepared if I give you a graph. Can you get your equations from it? Or can you match a graph to the equation if it were a multiple choice type of question? Use Desmos to double check yourself. Any questions on that one? What would we do to solve this? Okay, we have to get it equal to 0. So we need everything on one side, so we can subtract over the 10x. 16x squared minus 10x equals 0. First step to factoring is always to check for what? What can I take out of both of these? Okay, when you factor it out, it's like dividing. If you have 16x squared divided by 2x, what are you left with? If you have 10x divided by 2x, what are we left with? So now, the only way to get 0 when you're multiplying is if one of these things is 0. So 2x equals 0, or 8x minus 5 equals 0. So this one gives me x equals 0. This one, if I add my 5, divide by 8, we get 5/8. Make sure at the end we always write them in a solution set. That's with the squiggly brackets. Don't put parentheses. That makes it look like an ordered pair, which means something different. So make sure you're putting it in solution set. Don't write it like this. Let's look at 23. First, we always need these to be equal to 0. We can move things to either side, but before we factor, we always want x squared to be positive or negative. Positive. So let's go ahead, since x squared is negative, let's move everything to the right so it would become a positive. So if I want to do that, I would have to add my x squared. There's no other x squareds here. We would have to subtract the 3x. That leaves me a 0. Over here, if I had x minus 3x, that's negative 2x, minus 15 plus x squared, or we could write that as x squared minus 2x minus 15 equals 0. Now we have to factor that. Do we have a greatest common factor? No, that's the first thing we check. There isn't one. Then we look, if it's 2 terms, we check if we can do difference of squares. 3 terms, we check to see if we can do our shortcut. So x squared would just break into x. And you're looking for 2 things that multiply to a negative 15 and add to a negative 2. Alright, everybody with me here. The factoring some of you have struggled with, so make sure you're paying attention now and asking questions if we need to. What do we have to do at this point? Set them equal to 0. So you have options. Some of you need to write it out still. Some of you might be able to look at this and tell the answer. Either way is okay. So if we say x minus 5 equals 0, add the 5, we get positive 5. This one, x plus 3 equals 0. Subtract your 3, you get negative 3. So our answer is positive 5, negative 3. Is there a way we could use Desmos to help us check these? What would you have to do? Once you have it equal to 0, you could graph this on Desmos And then what are you looking for on that graph? And touches the x-axis. Now, you can't use that as the only way of getting your solution. If you just come to these problems and write down the answer with no work, you're not going to get credit. I want you to use that to check yourself, not as your sole way of doing the problem. Does that make sense? All right, 25. So we need it equal to 0, so that means we are going to have to subtract over the 7x and the 5. They are not like terms, so we just keep everything. 6x squared minus 7x minus 5 equals 0. Do we have a greatest common factor? No. So then what do we do on those? Slip inside. So this is x squared minus 7x minus 30. So we need two numbers, multiply to a negative 30, add to a negative 7. So then, we start out multiplying by 6, so we divide by 6. 10 over 6 would reduce to 5 over 3, so that's 3x minus 5. 3 over 6 reduces to 1 over 2, so 2x plus 1. And then what? Let me flip and see that. Add our 5. Divide by 3. Get 5/3. And negative 1. Questions on that one? Is this helping, guys?
Yeah.
26. Let's talk about these, especially the table ones. So remember, if it's linear, what are we looking for? Right. The first difference would be the same. Either add or subtract the same every time. If it's quadratic, we check the second difference. And exponential, we have to multiply or divide. All right, so we are looking, double check first. Did my x's follow the same pattern? Okay. So then let's look at our y's. To get from negative 5 to positive 25, what do we do? To get from 25 to 59, and to get from 59 to 97. All right, if it's linear, those will all match. They don't, so it's not linear. We have to keep going. We check the second difference. So how do you get from 30 to 34? And from 34 to 38? So if the second difference matches, then that means it is quadratic. Right. I know we didn't ask, but I'm going to look at the next two as well, just because when I graded the homework over these patterns, we had a little more trouble with it than the others. So double checked, my x's went down or went up by 2 every time, so that's good. How did we get from 38 to 26? To get from 26 to 14, and from 14 to 2. So those are the same every time, so that means it is linear. Right, this one, we can start off with the adding, subtracting. So we're going to see here we added 21, and then here we're adding way more, right? And this is going up really fast. So does adding seem like the way to go? So then I ask myself, okay, if I am at 7, can I multiply or divide by something to get 28? This is times 4. If you do 28 times 4, does it give us 112? And 112 times 4 is 448. So this is exponential. To decide growth or decay, we're just looking where the y is getting bigger or smaller. Bigger, so that's correct. When you graph an exponential, what does it look like? Yeah, it's like a curve either going up or down. So 29 would be exponential decay. Exponential because it's curved, decay because it's going down. 30, how would I decide what this one was? Or multiply it out, yeah. When I start multiplying, I get x squared minus 6x minus 1x plus 6. I don't even have to finish. As soon as I see the x squared, I know it is quadratic. You could also graph that one. If it's quadratic, the shape of it will be a parabola, that U, either facing up or down. If it's linear, it will be just a line. All right, 31. Go to Desmos and graph this for me. All right, what does it look like? Yep, it's curved. It's not a full parabola, so it's not quadratic. It is increasing, so this is exponential growth. All right, are we okay on those problems? Okay. The last two, when I taught it, I didn't require you to draw my graph. It was just using Desmos, so I would follow that same thing on the test. I'd probably give you a blank graph if you chose to draw me a picture, but you wouldn't have to. You could use Desmos to get those intersections. Are there any questions that we did not cover? Okay, so I'll probably have something like this on the test tomorrow. Any questions I'm doing? There's things like it on the test. We've done this, like every time you graph a quadratic, you have to tell me the axis of symmetry and the vertex and all that. I just didn't make you fill in the whole table to get the whole graph. So how do we find the axis of symmetry?
-12 over 2.
So what you need to remember is x equals opposite of b over 2a. That's the axis of symmetry. So we get -12 over -4, so x equals 3. Vertex, that's the x value. How do we get the y? Plug it in. There's a couple options. You can use the table. You can also just go through and replace all of our x's with 3's. Okay, and you can put that in your calculator. So did you guys get 14?
Yes.
So vertex is the point 314. Is that okay? Alright, if the graph is reflected over the x, move left 3 and up 6, write the equation.
-x. Plus 3. Plus 6. Plus 6.
You have to have the parenthesis around the x plus 3 because that whole thing has to be squared. So if you're moving left or right, it has to be inside the parenthesis. And then the plus 6 just goes on the end. All right. Is that one okay? All right, here's a question for you. I've given you the graph. I want you guys to look at that graph and answer some questions. No. The fact that it's just hard to see back there. Axis of symmetry, how do we have to write that? X equals. So, you're asking the equation, this line, the vertical line that goes through the middle. So that would be at x equals what? 1. So my vertex, the x is 1, the y, negative 9. What is the domain every single time?
All real numbers.
Yep, you can make that symbol, you can write all real numbers, it doesn't matter. The range.
Y is greater than or less than negative 9.
Greater than or equal to negative.
I mean,
yes.
yeah.
And if it's facing up, it's always greater than. If it's facing down, that's when it's the less than. Okay, zeros.
4, 2.
Yes. Those are asking where we hit the x-axis. So positive 4 and negative 2.
Because you put a negative in front of it.
Okay. If I asked you to get an equation from that. So if 4 is a 0, what would have to be in my factored form?
Negative 4.
That would be x minus 4. So that when you plugged in the 4, it equaled 0. If negative 2, then my factored form would have to be?
Plus 2.
Let's just leave it in factored form. Let's not multiply it out. What if I asked you to write your equation based off transformations? How did this graph move? Right 1. So to move to the right, it has to be x minus 1. And then it went down 9, so it would have a minus 9 on it.
No, I did that whole thing opposite.
What are you talking about?
I was gonna get it right eventually. I just didn't fill it up. I just started with that.
Oh, that works. Yeah, that would get you there. Okay, let's try a couple factoring problems. These will be the last types of problems that we do to review. Let's see, we've done 3s. So solve each of these.
Boy, don't you do it.
Still got that sucker in?
Why is it bent?
Ain't no one taking it from you, Cooper. You don't gotta eat it that quick.
Alright, guys, get to work. So the first one, we only have 2 terms. It's already equal to 0, so what can we take out?
X.
And you're left with? Okay, if you have 2 things multiplied that equal 0, you set each to 0. If we subtract our 5, negative 5. So our answers are 0, negative 5. Second one, before we can do anything, we have to get it equal to 0. So
Add
we have
the X and
Good.
subtract the 4.
Okay, so that gives us a 3x squared minus 11x minus 4 equals 0. Do we have a greatest common factor?
No.
No. So we do slip and slide. So x squared minus 11x minus 12. What multiplies to a negative 12 and adds to a negative 11?
Negative 12 and 1.
What do we have to do now?
Make them both be 11.
Divided by.
Yeah. First we have to divide by 3. So x minus 12 over 3, so x minus 4 3x plus 1 equals 0. Just set those equal to 0. And we get 4 and negative 1/3. Would you get the same answer if you set it equal to 0 up here before we finished our factoring? It would have eventually reduced to the same thing. The factoring isn't correct, but the zeros will turn out to be the same. So I know I've caught a couple people doing that, and it's correct in terms of finding the 0, but it's not the correct factoring at the end. So just be aware of that. Okay. Last one. What do we do? So we get 25x squared minus 9 equals 0. Do we have a greatest common factor? No. These are two perfect squares. So difference of squares, identical parentheses. One's plus, one's minus. Square root of 25x squared. Square root of 9. So set those to 0. So 5x plus 3 equals 0. 5x minus 3 equals 0. And then we're just solving this. We get a negative 3/5. And a positive 3/5. Okay, so we have reviewed everything that's on this test. Use Desmos to help you check your answers. How do we find axis of symmetry?
Yeah. Something like that.